Hi students, this is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 9, Applied Statistics. Here the learning objectives, these are the things to be learnt here. Time series data, components of time series, moving averages, seasonal variation, index numbers, weighted index numbers, tests for an ideal index number, statistical quality control, causes for variation, process control and product control. Okay, then first one, the straight line trend is represented by the equation capital Y that is equal to A plus B into capital X. This is called the line of best fit. Capital Y refers actual value and capital X refers time, and A and B are constants. The constants A and B can be estimated by solving the normal equations. The normal equations are sigma y that is equal to NA plus B into sigma x. Sigma means summation. And sigma xy that is equal to A into sigma x plus B into sigma x squared. If sigma x that is equal to 0, then A can be calculated by using the formula sigma y divided by n, and B can be calculated by this formula sigma xy divided by sigma x square. Now next formula, seasonal index, that is SI, seasonal index. Formula, seasonal average divided by grand average into 100. If the data is given in months, seasonal index for January, that is monthly average, that is for the month January divided by grand average into 100, and the seasonal index for the next month February equals monthly average for the month of February divided by grand average into 100, and so on. So we can calculate the seasonal index for all the 12 months right from January to December. Now the next one, if the data is given in quarter, year has 4 quarters, first, second, third and fourth quarter. Every 3 months will have, you can call it as 1 quarter. So seasonal index for 1 quarter, that is equal to, first quarter equals average for the first quarter divided by grand average into 100. Seasonal index for the second quarter equals average for the second quarter divided by grand average into 100, and so on. Seasonal index for third quarter and seasonal index for fourth quarter. Okay. Now we can get into that exercise, exercise 9.1, problem number 13. Start with problem number 13. So exercise 9.1, problem number 1 to 12, definitions and statement. Now question number 13, compute the average seasonal movement for the following series. Okay, you are given that year from 2002 to 2006, 5 years given, and quarterly production also given, first quarter to fourth quarter. You have to compute the average seasonal movement for the following series. Okay. So each and every year is divided into 4 quarters, first, second, third and fourth quarter. So quarterly production given. Okay. Now start with, you have to calculate quarterly total. Quarterly total right here. Quarterly total. Just you have to add 3.5 plus 3.6 plus 3.4 plus 4.2 plus 3.9. If you add 9 plus 2, 11 plus 4, 15 plus 6, 21 plus 5, that is 26. Carry 2, 2 plus 3, 5, 5 plus 3, 8 plus 3, 11 plus 4, 15 plus 3, that is 18, 18.6. Like that you have to do that for the second quarter, third quarter and fourth quarter total. Then you have to write here. Okay. So I have done that calculation for all the 4 quarters total over. Now quarterly averages. quarterly averages. That means this total is 18.6. 18.6 divided by, this is a total for how many years? 1, 2, 3, 4 and 5. So divide by 5. Like that. 20.8 divided by 5. 18.8 divided by 5. 20.8 divided by 5. Divide and write. We have to write. Okay. So I have done the calculation. Next step, we have to calculate the grand average. Grand average. That means have to add all the averages and divide it by 4. See, 3.72 plus 4.16 plus 3.76 plus 4.16. So divided by 1, 2, 3, 4 divided by 4. If we add, we'll be getting 15.8 divided by 4. If we divide, we'll be getting 3.95. That is a grand average. After that, you have to write the formula for seasonal index for first quarter. Seasonal index for first quarter. That is equal to average of first quarter divided by grand average. Average of first quarter divided by grand average into 100. This is a formula. Average of first quarter, you know very well, that is 3.72. First quarter average 3.72 and the grand average is 3.95. 3.72 divided by 3.95 into 100 equals 3.72 divided by 3.95 into 100. 3.72 divided by 3.95 equals, that is 0.941772 into 100. If you multiply, you will be getting 94.1772. This is the seasonal index for first quarter. Similarly, you have to calculate the seasonal index for second quarter, third quarter and fourth quarter. Now, SI for second quarter equals formula average of second quarter divided by grand average into 100. Second quarter average, here it is, average for the second quarter is 4.16 and the grand average is 3.95. That is equal to 4.16 divided by 3.95 into 100. 4.16 divided by 3.95 equals 1.05316 into 100. If we multiply, we will be getting 105.316. Okay. Even you can write that next digit is 4 here. So 4. Even if you write 105.32, that is also correct. It can be rounded up to 2 decimal places. So SI for second quarter over. Now SI for the third quarter. SI, seasonal index for third quarter. Formula average of third quarter divided by grand average into 100 equals third quarter average, here it is 3.76 divided by 3.95, correct? 3.76 divided by 3.95 into 100. 3.76 divided by 3.95 equals 0.951898 into 100. We will be getting 95.1898. Now seasonal index for the fourth quarter. Fourth quarter equals average of fourth quarter divided by grand average into 100. Average of fourth quarter, here it is 4.16 and the grand average is 3.95. 4.16 divided by 3.95 into 100 equals 4.16 divided by 3.95 is equal to 1.053164 into 100. You will be getting 105.3164. That's all. So problem number 13 is completed. We have calculated the seasonal index for all the 4 quarters. Then I will be teaching problem number 14 in the next video. Thank you, children.